Okay, in this video we're going to show the monitor panel part of this, the tank monitor part, and how it connects to the microcontroller. And these are the three different tanks that I have connected, but we're just going to do one since these are duplicated. And then they're done through the programming here for each individual one. Okay, so here's that circuit slimmed down just to one tank. So the software is just for one tank. I got it programmed for the fresh one, and then just enough to get the Nextion to work. So you can see as we ground out the different probes off the Squid, it changes 1/3, 2/3 full. And then I tried to clean it up and condense it a little bit. So this is what we'll be working with in this video. Okay, so we'll go over the diagram and of this. And one thing I realized I would have changed is this is where I'm connecting the 12 volt. So just to make it a little cleaner, I would have made this side the 12 volt rail and connected the 12 volt back here and just connected the 3 volt from here to here. So I think that would have turned out a little cleaner, but this is what we have to work with right now. So we'll go over the diagram. And in this circuit, the Teensy periodically sends out a 3.3 volt pulse from pin 23. That pulse is routed through a 1K resistor over here into the base of a transistor. The transistor emitter is tied to ground. So when it switches on, it provides a ground path for the MOSFET's gate. The MOSFET has a 10K pull-up resistor between its gate and source, here and here, which keeps the MOSFET normally off. When the transistor pulls the gate low, the MOSFET turns on, connecting the 12 volt supply at its drain output on its source. So that's going to supply our 12 volt over to here. That 12 volt output then passes through a 1K resistor into a voltage divider. It's made up of a 47K, that's going to be the positive side, and a 12K, that's going to get our ground, the negative side. The junction of those two resistors provides a scaled down version of the 12 volt signal that's safe for the Teensy's ADC. So that's going to go back over here to 22. This divided voltage is read on pin 22, which also has a capacitor to smooth the signal. So over here we got a capacitor. The Squid sensor ties into the same divider junction right here. Its internal resistor network provides alternate ground paths depending on the tank fill level, which pulls the divider voltage down by different amounts, right? So depending on if it's at 1/3, 2/3, full, or empty. And that's how the tank's level is encoded into the analog reading on pin 22. Over to here, right? So all this is tied together. So as the tank levels change, this will pull this down and change the voltage here. To make the measurement reliable, the system also uses a reference channel. The Teensy's pin 41 is connected to a second identical voltage divider. Same thing here, 47 and 12. Driven directly from the 12 volt supply. This reference path also has a capacitor, right? We're going to smooth that one out also. And provides a stable comparison voltage to the software, can measure voltage drop relative to a known baseline, right? So when I was trying to put this together, it wasn't working, it was never accurate, and I started realizing, hey, how does this know what the baseline voltage is? And so I asked chat to rewrite it so it had a baseline. So as we add tanks, we add other reference pins. They all can parallel to here, but they'll all have their own reference pin and their own send and receive signal pins. Okay, so now we'll actually go ahead and put this together. That's a Teensy 4.1. And then this is a level shifter. We'll go over that. That took me a long time to figure out how to make the Nextion work, because the Nextion works on 5 volt and the Teensy's on 3.3 volt, and you have to be able to shift those voltages. So that little module there allows us to do that. So here we're going to connect the 5 volt rail to the power in on the Teensy. That's the ground side. This is the plus 5 volt side. There's a close-up of where they're at. And then this is what I would have done different. I would have taken this 3 volt and I would have put it right to the level shifter and made that rail the 12 volt side. It just would have came out cleaner, but it's just for this video. It's not in the actual project. So that level shifter requires 3 volt to it and the 5 volt. And so here we're going to supply the RX and TX, so the communication for serial. I'm using serial 7. So you can see 28 and 29, you have RX and TX. And then here I'm supplying the low voltage side. So that's the ground, and then here's the 3 volts. And there's a close-up of what we just did. Now I'm going to do what they call the high voltage side, the 5 volt side. So the positive and the ground. That's a close-up of where those go. You can see HV and ground, high voltage. Then on this side later on, we'll hook up the Nextion. So its RX will go to TX on the Teensy, and then vice versa. The Nextion TX will go to the RX. So here's a close-up of that module. There's a few different ones. I probably have 2 or 3 different ones I've tried. And that's just a close-up. You can see that's the SMD, the surface mounted devices on there. And that's what I'm going to be trying to learn next when I get done with this project. So they have different MOSFETs and different things you can use, so I can kind of condense this project down on a smaller board. Okay, now we're going to install the MOSFET. And I'm sure there's another way to do this, and I think it involves those SMD type devices. So what you have to do with the MOSFET is you put a 10K resistor across its gate and its source, and that makes sure that it stays open until we change the gate. And then I'm installing the transistor, so you can see the collector and the gate are in the same row. And then the emitter on the transistor is getting a ground signal. Okay, and then here's a 1K resistor that's going to the base of the transistor. So there's a close-up there of what we did. So on this particular project, pin 23 is going to be what I call our signal, or our output signal to turn on the transistor, which in turn turns on the MOSFET. Because the Teensy puts out a positive and the MOSFET needs a negative to turn on, I put a transistor in between. So hopefully in the future I'll figure out a different way, more modern way to do that. So there we're installing the wire from the pin 23 to the resistor for the base. Okay, showing you there the path. There's up close for pin 23. There's the up close. You can see the blue wire is actually in the row with the resistor in the row with the base. All right, now we're going to connect the drain of the MOSFET. So that's going to be the 12 volt output. When we get that pulse from the Teensy, we'll actually get that voltage going through that red wire. You can see there it's going to the middle pin. And we put another 1K resistor, and we're going to feed that into a voltage divider, because that we got to get it to a working voltage for that Teensy. So we can't put a 12 volt signal to that. So the voltage divider, the positive side is going to one side of a 47K resistor. The other resistor is a 12K, as you can see here, and that is going to the ground side. Then you can see the squid is in between the wire that goes to pin 22. So here's the wire for pin 22. And it's connected at the junction between those two resistors. And we'll demo that later with the meter so you can see the voltages. And it also gets a 104 capacitor there to keep that steady. Okay, so for this to work correctly, I needed a reference voltage because the pin 22 didn't know what to compare it to. And so I set up pin 41 as my reference voltage. So we just did an identical voltage divider. And you can see there, the center of that's going to pin 41. And you can see where our 12 volts is going to feed that circuit. It goes through another 1K resistor into the voltage divider. And now we're just putting in the wire between the voltage divider and pin 41. It also is going to get a capacitor. Keep that reading smooth. Okay, I'm just adjusting the wires to get everything to fit, putting in the capacitors. And then that's where I put my 12 volt. Like I said, looking back, it's kind of sloppy having to use that jumper wire like that. So you can see where I'm feeding the 12 volt at. And then to hook up the Nextion, I got a different jumper. I didn't want to modify the connector that came with the Nextion, so I bought some other ones. That's why there's heat shrink on the end of those, so I could color code them correctly. And you can see we're just connecting those where they're supposed to go, like I explained earlier. We're connecting the power to 5 volt. Now we're connecting the 5 volt power from the converter. That's a little converter I'm using. That's where we're getting the 5 volt from. And so we power it on, and it went to full before I plugged anything in. And I was a little confused because I have another board like this already set up and I'm just copying it. So I actually have a board that I could see. But it's hard for me to see the colors on the resistors. So I just got 2 of them backwards. I got the 1K and the 12K backwards. So once I reversed those, that fixed the issue. So here I'm showing you I had another one mocked up already, so I had something to copy it while I was making the video. Now with it fixed, you can see the 1/3 reads 1/3, 2/3 reads 2/3, and the full reads full. And this is what I'm referring to with the Squid. I mean, there's other types of sensors they use on tanks. This is just the one I preferred to use since I had one laying around. And you can see the red wire is your read pin, and then your full is your orange, green is 2/3, and yellow is 1/3. And it's basically just another voltage divider. There's just two resistors in there. I've cut those open before, and they're kind of a weird value. But that's what I'm referring to when I say Squid. Okay, so we got some power mocked up here. I'll show you our 12 volt is this circuit here. And then our 5 volt is coming from a power supply there. And then the 3 volt comes from the Teensy on this rail. Okay, so that 3 volt is primarily for that. Then we can see here that this is sending out a pulsed signal. See, real quick, but it remembers the results, and that's what it displays to the Nextion. So we can see here, there's a pulsed voltage. And then if we connect the Squid, see it's pulsing every so many seconds. We'll hook up our 1/3. We get a measurement there. Okay, then we hook up our 2/3. You'll see the measurement will be different. And then we hook up our full, it's going to say 0 volts. So 0 volts is what's going to read full. And then we can see here our 41, that's giving us our reference voltage. Okay, so 41, that's our reference voltage going through that voltage divider. So that's our 12 volt, but we have to get it down to a voltage that this can deal with. So we can see here again, our 1/3, you can see it flashed up a voltage there. And it does it really quickly, so you can see there. I haven't actually hooked these up to tanks yet, because if you know how to diag a monitor system like this, you know the fresh tank reads different. So I don't know if I'm going to have to modify the software. So I'll try to put a link for the code, this minimal code for this little project. At the very end, we'll do the whole code for the whole thing in another video. But originally I was going to refurbish an old trailer, and I wanted to make my own control center. And so since my injuries, I don't know if I'll ever be able to do the trailer part, but I thought, while I'm sitting here, I might as well learn how to build a control center. And that's why I'm making this series of these videos. And this is the holding tank portion of that. And we'll do another one. Probably the next one will probably be the reversing polarity relays, like if you want to move a slide out or an awning. And so that's it. And thanks for watching. We'll see you next time.